we are looking at this paper. Let's go straight to question 1. Now, they're saying a mathematics teacher was curious to establish if a learner's mathematics marks influenced the physical science marks. Now, in the table below, the mathematics and physical science marks of 15 learners in her class are given as percentages. Okay, so these are the percentages that we have. We have the mathematics, and then we have the physical science. And then there is a scatter plot for these marks, the physical science, the mathematics. So note that the top ones will always be the x-axis, and the bottom one will always be the y-axis. So hence they have done this for us. Right, so now the first question that they're asking, determine the equation of the least square regression line for the data. Right, so to get this, we are going straight to our calculator, press mode, and then we go to statistics. Right, and then we go to number 5, which is ax plus y equals to ax plus b. Right, and now we will punch the x values. So it's 26, and then equals to 62, and then we press equals to, then 21, then equals to the 33, equals to 53, equals to 76, then equals to, then 32, 32 equals to 59, 59 equals to 43, 43 equals to 33, 33 equals to 49, 49 then equals to 51, 51 equals to 19, equals to, then there's 34, equals to, and the last one is 85, equals to. Now we are going to do the ones for physical science. So it means we come to this side, and then we go up on our screen. Make sure that we have the first one. Right, for physical science, it starts with 34. So we have 34 equals to 67. 67 equals to 28, equals to 46. 46 equals to 65, equals to 76, equals to 26, then 73, equals to 50, equals to 39, equals to 57, equals to 51, equals to 24, equals to 41, equals to 80, equals to. Right. Now we have all the data that we wanted. So we go to AC or on. So it's better to go to AC. And then we press Shift, then 1. Right. So under Shift 1, we go to okay. We have A equals to 9. A equals to 9,5. B equals to 0,91. And the R equals to 0,95. Okay, so we have all these variables. Please make sure that you write them all. Okay, so the equation is always y equals to a plus bx. So we have our equation as y equals to a plus bx. So when we substitute the values we calculated, so we have a, which is 9,5 plus b, which is 0,91x. Right, so that is our equation. So we can go to the next question. Draw the least square regression line on the scatter plot provided. Okay, so because we don't have the answer sheet here, we will just draw it on the question paper. So we will take this as our scatter plot. So we take this and then we are going to draw the equation of the least square regression line. Now it is always better to we use this equation that we have. Let's get our y intercept. We know that x is 0, so we will have 9,5. So it means we have the y intercept somewhere before 10, so somewhere there. Okay, and then if it was to go that side, we will use that line, but let's just take any value. Okay, let's take x at 20. So we will have 0,95 plus 0,91, and then we put a 20 there. We just want to see. So we have SD, so it's about 19,15. So as we go to our calculators, 20, it's 19,15. So we will have something there. So and then we can now draw a line. Right, so something like that. So this is the line of best fit, but remember, maybe yours should be better because you'll use a ruler. Just join the two points there and you'll have something like that. But generally, if you don't use the equation that we have, you just get something that will be in between these all points, just something in between. So a line that will fit all these points there. Right, so but in any case, that is our line of best fit. So that's what we have. So we go to the next question. What is this? 1.3. Predict the physical science mark of a learner who achieved 69% for mathematics. Now remember, mathematics is represented by the x-axis, so we are going to check. It means they want the y value, so we just substitute. So it's simple substitution. This one, it's 1.3. So for 1.3, we just substitute on this equation, so we just get y equals to, this is 9,5 plus 0,91, and then we substitute the mathematics mark, which is 69%, so we'll just put a 69, right? So, and then simply punching your calculator there, you will get 72,29. Right, so that will be the mark for physical science if a learner got 69% in mathematics. Right, so we'll predict that way. So 1.4, 1.4, the question is, write down the correlation coefficient between the mathematics and the physical science mark for that data. So remember, we said we just write them all here because we know there's no way they cannot ask. So already we have written it down, so you just write the correlation. It's R, which is 0,95. Right, so that's why they just say write it down. So that's why I advise that when you get your A and your B, you must just have all of them, all the three are automatically, because you're going to switch your calculator off and on, and then you might even forget. And now when you have to go back, it's another long process. So always write down the R somewhere, somehow. Okay, so 1.5. Comment on the strength of the correlation between the mathematics and the physical science marks for the data. Right. So if you can all see, it's the R is 0,95, which is 95%. So this is very strong. It's very strong. Very strong and positive. Now it's 1.6. Okay, what is the question on 1.6? It's also 1 mark. Now, what trend did the teacher observe between the results of the two subjects? Okay, can you see 62, 67, 21, 28, 33, 46? So the higher the mathematics marks, the higher the physical science marks. So that's our conclusion. We can just say the higher the maths marks, the higher the science marks. Right, and that's it. I hope you enjoyed that question. Let's look at question 2. The number of aircraft landing at the Kinshasa International Airport and the Port Elizabeth Airport for the period starting in April 2017 and ending in March 2018 is shown in the double bar graph. So if we zoom it in, we are able to see the light ones, the dark ones as indicated, Kinshasa there, and the light ones there as Port Elizabeth. Okay, right, let's go straight to the question. 2.1 for 1 mark. The number of aircrafts landing at Port Elizabeth Airport exceeds the number of aircraft landing at Kinshasa International Airport during some months of the given period. Now, during which month is this difference the greatest? The one is bigger with a small margin. Oh, look at that. I think this is bigger. This is bigger. It's a bigger margin. What month is this? They're asking about this month. Oh, okay. So the month is July. So we will say exactly 2.1. We just simply tell them, oh, during July month. Right. So that's what they want. Okay, let's go to the next question. And the number of aircraft landing at the Kinshasa International Airport during this month. So these are the numbers. So they want us to calculate the mean of the data. All right. As we calculate the mean, can we just even before we go to the mean, let's go to the next question. It also says calculate the standard deviation for the aircraft at Kinshasa International Airport for the given period. So I want us to calculate the mean and the standard deviation on the calculator. Now we press mode. We go to statistics. In this calculator, it's depending on your calculator, but go to statistics and then go to when you see VAR on your calculator, so you just go there and then you punch the data, and in this case we have 2182 equals to, the order doesn't matter, so we have 2323 equals to, and then we have 2276, okay, it's 2267 rather, equals to, then 2334 equals to, and then 2346 and then equals to, then we have 2175 then equals to, we have 2293 then equals to, we have 2263 equals to 2215 equals to, then 2271 equals to, then 2018 then equals to, then 2254 equals to, right. So when we are done with that, then we can cancel, and then we press the shift, then the 1, and then we go to our var. Okay. Right, so we see the standard deviation there, the mean is given by 245. So we have the mean is 2245 0.083 we can just round it off to 0.8. Then the standard deviation it's 26. No, the square root of that. Wow. We want the square root of that, so which is actually the standard deviation is number 3 on your calculators. So it is 86.30. So if you see a QX, then you know that it's the standard deviation. So it's 86.30. So you analyze your calculators properly. This X with a bar is the mean, and then the QX, it's the standard deviation. So it's 86.30. Okay, so right, let's go back to our question. We had question 2.2, calculated the mean. Okay, let's write it properly. 2.2, the mean, which is represented by this, or we can just write the mean equals 22245.08. So that's our mean. And then the next question is calculate the standard deviation. 2.3. We have already calculated the standard deviation. Is 86.30, and then we go to 2.4. Now let's look at the question. Determine the number of months in which the number of aircrafts landing at Kinshasa Stadium International Airport were within one standard deviation from the mean. Okay, within one standard deviation from the mean. Right, in this case, we are going to take our mean and then we subtract the standard deviation, and then we take it again, we add, so that we can have boundaries. So we have these boundaries. Okay, we have where we take this and subtract. So boundary number 1, we just take the mean, which is 2245.08, and subtract 86.30. So we can do that with our calculators. So we will get 21. If my calculator is doing well, so we will get 2158.78, and then this other boundary where we are adding them together, we actually have 2331.38. Right, so now these are our boundaries. So they are back to the question. They said how many are within. In other words, okay, let's have a background of this. This side is actually below. Here is our within or between, and this one is above. So if they want outside, it means we will add the ones here and the ones there, because sometimes they may say outside, but now they say within. So we're going to count everything that is every number that is within these two. So anything above 2158.78 and below 2331.38. So we go back to our table, and so let's just tick them on the table there. 2182, yes, we can take it. 2323, we can take that. 2267, we can take that one. 2334, no, it's above 2331. 2346, no. 2175, yes, we can take that. And then 2293, we can take that. 2263, we can take that. 2215, we can take that. 2271, we can take. 2018, no, we can't take that one. It's below our 2158. What about 2254? Yes, we can take that. And so they wanted to know how many are within. So we just simply count this. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it means our answer in 2.4, it's actually 9. Our answer is 9. Simply 9. So it means there were only 9 months. There were only 9 months where what is happening? Let's check. Determine the number of months in which the number of aircraft landing at the King Shaka International Airport were within 1 standard deviation from the mean. So the answer is 9 months. That's question number 4. So let's look at 2.5. Right. Now 2.5. Let's see which one of the following statements is correct. All right. During December and January, there were more landings at the airport, at the Port Elizabeth Airport, than at the King Shaka International Airport. During December and January, okay, we simply check whether the statement is true because they want the one that is correct. So let's look at December and January. They say during December and January there were more what in December and January. Let's see, December and January, that statement number 8. During December and January there were more landings on the Port Elizabeth. So in other words, Port Elizabeth more than King Shaka. So meaning we need to look at the PE must be above. The lighter one must be above the darker one. The lighter one above the darker one in December and in January. Oh, December, it's below. Even in January, it's below. So this statement is definitely not true. Okay, let's check another one. Number B, they're saying there were a greater variation in the number of aircrafts landing at the King Shaka International Airport than at the Port Elizabeth Airport for the given period. No, we have already seen that that cannot be. So this leaves us with number C, so that can only be our answer. So it says here the standard deviation of the number of landings at the Port Elizabeth Airport will be higher than that one of the standard deviation of the number of landings at the King Shaka International Airport. Yeah, this can be true because if we look at the Port Elizabeth, the PE in most cases is higher in most cases. So obviously the standard deviation will be correct. So we will go with option C. Let's choose C. In this case, let's choose option C. So C is our correct answer. Right, question 3. There it's analytical geometry. So let's look at what we have here. They're saying in triangle TSK is drawn. Triangle TSK is drawn. Okay. The equation of ST. The equation of ST. So this line we have its equation, which is given. So it's, remember, it's given. It's y equals to 1 over 2 x plus 6. So that's the equation of this line. ST cuts the x-axis at -4 and 4. There we are. So, okay. ST cut the x-axis at M. ST cuts the x-axis at M. Oh, that's our M, sorry. And then W is -4 and 4, so that's W. And it lies on ST. And R lies on SK, such that WR is parallel to the y-axis. So WR is parallel to the y-axis. Now, when it is parallel to the y-axis like this, they're trying to tell us that the x value here is the same as the x value there. So meaning we can just say this is -4 and 0. So it's actually -4 there. The x value is -4. So let me write it properly. So the x value here is -4, right? And then they say all right, so right, WK cuts the x-axis at V. It cuts the x-axis at V and the y-axis at P with the coordinates 0 and -4. So that one is given to us. It's shown there. KS produce cuts the x-axis at N. So there we are. So TSK is theta. TSK is theta. The TSK. So there's our theta. Now let's go straight to the question. Calculate the gradient of WP. 3.1. Gradient is M. So we just say, okay, let's say it's y at W minus y at P divided by the x value at W minus the x value at P, which is at W, y value is 4 minus at P, the y value is -4. Please include the negative. So the x value at W is -4, but at P is 0. So 4 minus -4, it's a +8 over -4. So it's actually -8, +8 over -4, it's -2. Right, so that's number 1. It's 3.1. Right, can we go to 3.2? Show that WP is perpendicular to ST. WP is perpendicular to ST. So we are just going to calculate the gradient of ST. So if the gradient of ST, it's actually when we multiply it with WP, we're going to get a -1, then we know they are perpendicular. So already we have the gradient of WP. So this is the gradient of WP. So we want the gradient of ST. So we don't even have to calculate because already we have the graph. So we are given the gradient there. We have the equation. So the gradient of ST equals to half. So when we take the gradient of ST and multiply it with the gradient of WP, let's see what it gives us. So this is 1/2 multiplied by -2. So you can see it's -1. Therefore, WP is perpendicular to ST. Right, so that was 3.2. So sorry, so that's 3.2. Now let's go to 3.3. So it says if the equation of sk, now we have equation of sk, that is 3.3. So we are given what sk is represented by 5y plus 2x. 5y plus 2x plus 60 equals to 0. So that is the equation of sk. Now, what do they want with this? Calculate the coordinates of s. Oh, coordinates of s, the coordinates here. Now, here at s, that's where our line sk is meeting with our line st, and we have both lines, so we are simply going to actually do simultaneous equations on this one. So we will just substitute the one. So remember that first one, y is half x plus 6. So where we see y, we will simply put 1 over 2x plus 6. So we can now calculate x. So this is 3.4. Okay, 3.3, yes. So it's 2x plus 60 is 0. Now this is multiplying, removing the bracket. So we will have 5 over 2x plus, now this is 30. 5 times 6 is 30. And then plus 2x plus 60 equals to 0. I can simply multiply by 2 throughout. So we'll have 5x plus 60 plus 4x plus 120. I'm multiplying everything by 2 equals to 0. Okay, numbers one side. So we have the 4x and the 5x gives us 9x. The 60 and the 120 gives us 180. So we can take it to the other side and it will be negative 180, giving us x to be 180 divided by 9, which is actually 20. Right, so with a negative, it's negative 20. So we can substitute the y value back. So y, it's 1 over 2x, which is negative 20, then plus 6. Right, so let's just substitute on the equation. We're saying y is half into negative 20 plus 6. So let's just punch our calculator there. Half of negative 20 is a negative 10. Negative 10 plus 6, it's actually a negative 4. So it means the coordinates, the given coordinates, they are, so we have a negative 20 and negative 4. So that was the question asked. So those are the coordinates of s. So it means the coordinates of s are negative 20 and negative 4. Let us look at question 3.4. 3.4. Now, it reads that calculate the length of WR. The length of WR. Now, remember they said that WR is parallel to the y-axis. So if these two lines are parallel, it means that the x value here is the same throughout. So the x value is the same. So in other words, on R, we already know the X value. Therefore, we will actually say that WR, it's the Y value at W minus the Y value at R. Right. So already we know the Y value at W is 4. So all we need is the Y value at R. So if we can get the Y value at R, then we'll just say 4 minus whatever we get on R, and we get our length of WR. So now here at R, we said we already know the X value, which is negative 4. Now we're going to substitute this negative 4 on the equation that we have, the equation of SK. We were given in 3.3 that the equation of SK is 5y plus 2x plus 60 equals to 0. So we know the X value, which is negative 4. So we will have 5y plus 2 times a negative 4, then plus 60 is 0. So we will have a 5y, this is negative 8. So a negative 8, when it comes, we add it with 60, it's positive 52. So taking it that side, it is going to be negative 52. So the Y value, it's actually negative 52 over 5. Right. So therefore, as we have said there, we said that WR is the Y value at W. The Y value at W is 4 minus the Y value at R. We just calculated it. We said it's negative 52 over 5. Right. And then giving us the value of WR to be, this will add, so it will just give us 72 over 5. So to get 3.5, we want the size of theta. So the size of theta, so we are going to use this line as K, and we will get this inclination here, which is beta. And then we are going to use this line here as W, as MW, and get this inclination here. So that will help us to get theta, because theta is now simply this angle here and plus that angle there. Right, so let's start right away. Now angle beta, we will, let's say tan beta, tangent of beta equals to the gradient. So the gradient of this line here, we already know that it's a negative 2 over 5. And then that will help us to get beta. Now beta is, therefore we press to get the angle, we have a shift tangent of this angle, but then because it's negative, we might as well start with the 180 and we subtract this angle, shift tan this angle. So we will get, as we can just press it on our calculators. We can just use our calculators to actually get the answer there. So it will simply give us 158 comma, we can just say comma 2. So it's 158 comma 2 degrees. So that is the size of beta. Now when we know beta, then we can get the size of this angle there. So that angle will be, it's actually angle MNS, angle MNS. It's 180 minus that angle 158,2, which is actually it gives us 21,8 degrees. So we know the size of this angle. Now we want the size of this angle here. We know the two are vertical opposite, so we are going to use the gradient of the straight line there. So the straight line is having a gradient of half, so we will say like we did with that one, tangent of our angle, let's call it WMV or O, doesn't matter the line, so it's our angle. So tangent of that equals to the gradient, which is actually half, right? And then this one we just punch it straight as shift tan half, because it's a positive, so we don't have issues with negative. So we know that WMV is, the angle is, if we just punch our calculators, we will get a 26, maybe 57, right, to rounding it off. Now to get theta that they're looking for, we're just going to add the angle that we got there, and then we know that these two angles are vertical opposite angles, so they are equal. So we just add this angle that we got here, and then we get that angle there. So it means theta, it's actually 21,8 plus 26,57. Right, so we add the two together, and then it gives us 48, around 48, maybe 37. So that is the size of theta. Okay, question 3.6. Let L be a point in the third quadrant such that SWRL, in that order, form a parallelogram. Calculate the area of SWRL. Right, so L is in quadrant number 3, so it's somewhere in this quadrant. So they are saying S, there is our S, then we have W, we have R, and then we have some L somewhere. Right, they're saying this forms a parallelogram. So it means we have some parallelogram there. Okay, something like that. So this line is parallel to this line, and this line is parallel to that line. So this thing forms a parallelogram. So this is our L. Now we want the area of the parallelogram. So in this parallelogram, we are going to need two things. Already we have the angle, which is 48,37. Now we are going to need the length. We need this length, SW, and we need the length, WR. Right, as we were calculating, we know that we have already calculated the length of WR, so we are just going to calculate the length of SW. So the main calculation here will be this length, right? Now, we want the area of this parallelogram. So if we can get the area of this triangle, so we can just double it, because now these triangles are congruent. So we are going to work on the area of WSR. Now remember, the coordinates of S is -20 and -4. The coordinates of R, it's 4. We set the Y value, the X value is 4, and we have calculated the Y value in question when we were calculating in question 3.4. So remember, we have calculated it. We said it's -52. Let's just write it so that we remind ourselves, over 5. All right, so it's 4 and 52 over 5. So now we already have the angle theta. We calculated it above. So all we are going to do is to get the length of SW and the length of SR, so that we can use our sine rule. We can say it's half this side times this side, the sine of this angle that we have here. Okay, let's start. Now let's start with WS. So the length of WS is simply the square root of we have X values, which is -4 minus -20, so we can just say it's +20 all squared, then plus the Y values, it's a 4, minus -4, so it's going to be +4 all squared. So the length of WS, so this is 16 squared plus 16 squared, so it's the square root of 16 squared. If we just punch that on our calculators, and then plus 4 plus 4, it's 8, the 4 and 4, it's an 8, so it's actually 8 squared. Right, so the whole thing will give us 8 the square root of 5. Right, that is the length of WS. Now we do the same with SR. We want the length of SR. Now this will also be the square root of x value at S is negative 20 minus 20 minus 4, so it's going to be plus 4 squared, and then the y values, it's a negative 4 and then plus, because it's minus 52 over 5, so it's going to be plus 52 over 5 all squared. Right, so if we punch this on our calculators, we 16 and the square root of 29 all over 5. Right, now I have SR, I have WS, I have the SR and the WS, so I can use the sine rule, the area rule. The area will be half multiplied by the 8 root 15 multiplied by the 16 root 29 over 5, the sine of the included angle, which is 48,37. Alright, so if we just punch this on our calculators, we will simply get something like 115,206, and now we double that, so we will get the area of SR, okay, SW RL will be double that, so it's 2 times 115,206, which is giving us, we just multiplied that by 2, so I'm getting 230,41. Okay, that ends our question number 3. Thank you very much. This calculator that I've been using is called Scientific Calculator Plus 991. It is very good. I've downloaded it from Play Store.